Assalamu alaikum guys. So in today's lecture we are going to do our topic scalars and vector. Okay. So first of all, what is a physical quantity? A physical quantity is any quantity that can be measured and has a unit. This is the basic definition of physical quantity. Okay. So now let's start with scalar. So we have to do it like very fast, so that's why we don't have to waste time. So now let's start with scalar. So what is a scalar quantity? Yes, so scalar quantity is also a physical quantity. Okay, there are two types of physical quantity. One is scalar and one is vector. So in this scalar, what's the definition of scalar? It is the magnitude only. Okay, and does not depend on direction. Like for example, speed. Let's say we take speed. Speed can be in this direction, this direction, or anywhere. Okay, while if we will see about the velocity in the other. Okay, so now here are some examples like, for example, time, distance, speed, temperature, mass, density, energy, work, power. Okay, now let's see vector. Now, what's the basic definition of vector? That it has a direction and a magnitude. Okay, it has a direction and a magnitude, means the unit. Okay, both are the same. So in this, let's take force, velocity, acceleration, moment. Like for example, velocity is in straight direction, right? Like if we draw a straight line, I know this isn't a straight line, but if you draw a straight line, then and this straight line we will call it velocity. Okay, like and moment, momentum, all are velocity. Vector definitely the examples. Okay, now here is graphical representation of vectors. Now, how do you represent the vectors by graphically? So the magnitude and direction of the arrow, and the magnitude means the length of the arrow. This is how we represent vector graphically. Or let's see, for example, this. If we see that 10 Newton is there and 2 Newton of force is applying at the right, while minus 5 Newton is on the left. So how many when we total these, it becomes 12. When we total this, it becomes minus 5. So when we calculate it, the answer will be 7 Newton. Okay, to the right. This is the opposite vector, means the opposite force force, applying on an object. Okay. So now, if we use the Pythagoras theorem, first of all, let me tell you how do you draw, uh, how do you represent it graphically. So, for example, this is a box, okay, and on this box, on the up way, uh, let's talk about like 3 Newton of force is applied, okay, on the right way, 4 Newton of force is applied, okay. So, first of all, what do we have to do? We have to make a scale, okay, like for example, 1 centimeter is equal to 1 Newton, okay. Then what do we do is that we draw like it's 3 Newton, we draw 3 centimeter. Okay, like for this 3 centimeter line going upward, it represents 3 Newton. And in the base of this, we draw a 4 centimeter line to represent, like this is 4 centimeter, right? To represent what? 4 Newton. So for this is how we represent it graphically. Now there is another topic, that how do we get sorry. So the first rule is like the head to tail rule, okay? So in this head to tail rule, what do we do? Wait. First, we choose a vector as a first vector. Like for example, vector, okay, this is the graphical representation. Okay, so first of all, here it's written choose any vector as a first vector. Like for example, this is the first vector. Take the second vector Okay, put the tail of the second vector head of first. Okay, so the resultant from the tail of first to the head of second. Okay, so for example, like it's basically seeing that draw a line from here to here, and then we have to calculate this line by a scale, and this will give us the, like for example, it's 5 Newton. Okay, 5 centimeters. So this where we have put the scale 1 centimeter is equal to 1 Newton. You can put the scale at your choice. Okay, so it isn't fixed. So and then we get 5 Newton or 5 centimeter. Okay. Now the other method is the Pythagoras theorem. Okay, is the Pythagoras theorem. It only like helps if it's the 90 degree. The head to tail also works only if it's 90 degree. Okay. So now what is it like? For example, wait, I think this line isn't straight. Let me draw a straight line. Like I'm trying to draw, but lack of practice. Cause okay. So let's suppose here's 3 Newton and here's 4 Newton. The same thing. Okay, the same which we did up. So in this, we do the Pythagoras theorem. In Pythagoras theorem, what is it? H square is equal to a square plus b square, right? What is this a square? A square is the height, b square is the base, okay? And h square is the hypotenuse. So in the Pythagoras theorem, we find if two sides are given, we find the third side, okay? So in this, it is 3 Newton plus 9 Newton, right? Sorry, 4 Newton, 4 Newton. So let's take h square is equal to 3 square plus 4 square, and then it's 9 plus 16, I think, yeah, 16. And then we remove the square from here, and it becomes under root and 25. And the 25 under root, like the 25 square root is 5 Newton. Okay, so this is the what? This is the resultant force. Okay, so basically Pythagoras theorem is more accurate than the head to tail, because in the head to tail there are some errors, like there are some physical errors. Okay, you got it until now. So now let's see this part. Okay, so for example, here it's given 5 Newton and the base is given 10 Newton. How do you find it by Pythagoras theorem? First we write this equation. Okay, then we solve it, that 5 square is 25 and 10 square is 100. Then we put this square from here to here, make it under root. Okay, make it under root, and then we add these, it's 125, and when we solve it, the under root, it becomes 11.2 Newton. It's basically 11.18. Okay, 11.18 Newton. But we round off to make it three significant figure. Okay, three significant figure. Okay, okay. For because it's us to give answers mostly in three significant figures, so hence you have to keep it in three significant figures. So that's it, guys, for today's class, and I hope you like it. It was a basic chapter, basic unit, not a chapter, of course. And I hope you understood it, because these notes were also made by some professors, teacher. Okay, so that's it, guys. Allah Hafiz.